हेलो स्टूडेंट्स, वेलकम टू फिजिक्स पाठशाला। आज हम पढ़ेंगे द कंटिन्यूइंग पार्ट जो थर्मल प्रॉपर्टी ऑफ मैटर वाज गोइंग ऑन। थर्मल प्रॉपर्टी ऑफ मैटर के थर्ड क्लास 3 third lecture we can say. This will study about calorimetry, that is heat measurement, that is calorimetry. Here we focus on how to measure heat. Under this heat measurement, we will be studying different heat capacities. First, we will discuss what is heat and its unit. Then, mechanical equivalent of heat, water equivalent of heat, and different heat capacities. Under heat capacity हम लोग पढ़ेंगे what is heat capacity, what is specific heat capacity, what is molar specific heat capacity or molar heat capacity. Then we'll have molar specific heat capacity under constant pressure and at a constant volume. Correct? Then we'll have relation between these two molar heat capacities. Let us now focus what is heat. Heat, as we discussed already, some form of energy that transfers from an object with higher temperature. Suppose object A, object B is there. Object A temperature 1, temperature of object B is T2, and temperature above A let more than T2. In this case, some form of energy will transfer to B. कैसे जाएगा? As you know, this temperature indicates the internal energy of a molecule. That means at which the molecule having more energy will start vibrating at higher motion. जो मॉलिक्यूल के पास ज्यादा काइनेटिक एनर्जी होगा वो ज्यादा वेलोसिटी के साथ वाइब्रेट करेगा। अभी बी के पास कम टेम्परेचर है, मतलब कम काइनेटिक एनर्जी है बी का मॉलिक्यूल का, तो बी मॉलिक्यूल ड्यू टू इट्स लेस काइनेटिक एनर्जी कम वेलोसिटी के साथ वाइब्रेट कर रहा है। ए का मॉलिक्यूल हायर वेलोसिटी के साथ वाइब्रेट कर रहा है। तो दोनों जब कांटेक्ट में आएंगे दोनों देयर विल बी collision between molecules of A and molecule B. During this collision, there will be some transfer of energy of molecule of A to molecule B. In this manner, some energy transferred and some energy we say is gained or absorbed by molecule of B. तो इनका पास एनर्जी absorb किया, due to this energy increased or temperature is increased. Now temperature of B increased, temperature of A decreased. They will start giving energy till T1 dash will be T2 dash. That is final temperature of T1 is T1 dash. Final temperature of B will be T2 dash. till T1 dash will be T2 dash, they will start giving this kinetic energy from molecule of A to molecule B. So in that manner, we say during this process, the energy in the form of heat, that we have given the name heat, but it is the energy, kinetic energy has been transferred from object A with higher energy to the object with lower energy. That means object with higher temperature to object with lower temperature, energy has been transferred, or we say heat has been transferred. When we say heat has been transferred from object with higher temperature to object with lower temperature. Actually क्या जा रहा है? Actually the energy associated with the higher temperature, उसके बाद ज़्यादा एनर्जी था, ज़्यादा काइनेटिक एनर्जी था, ज़्यादा वेलोसिटी था, वो जिसके पास कम था उसको उसने ट्रांसफर started giving. Correct? In that manner, heat has been transferred. Abhi question is, what is, if it is energy, then what is its unit? Unit will be joule in SI system, and it is calorie in CGS system. What is the relation between calorie and joule? 1 calorie of an heat equal to 4.861 joule. 4.861 joule, or we say 4.2 joule. So this heat is a non-mechanical work environment. During this heat transfer, during this energy transfer, there was no mechanical work has been done. Hence, we say heat is a form of energy transfer. It is a form of energy transfer. It is always linked to heat transition or heat transfer. Once this heat will enter into B molecules, so at that time we cannot tell the heat of molecules. We will say it will not convert to, now it will convert to its internal energy. It will internal, उसका molecule का internally part हो गया, उसका internal part का energy part, internal energy का part हो गया. That means जो भी heat जाएगा energy, it will start increasing its internal energy. At that time we will not say that heat is increasing, heat of the molecule is increasing. We will say internal energy of the molecule B are increasing. So heat term is linked till it is in energy is in transition. Energy is transmitting. Correct? Now the amount of energy that is which is transferred, or we say heat, it is in that transfer. No mechanical work has been done or linked. It is energy has been transferred purely due to collision between molecules. Correct? There is no external force, or there is no involvement of any displacement of mass as a whole. Mass as a whole is not displaced. Mass of B, means object B was as usual, it was there. Object A, it was as usual, it was there as a whole. There is no displacement of either A or B. There is no involvement of any external force. Hence, we say it is a non-mechanical type energy transfer, because there is no involvement of any mechanical work during this energy transfer. Hence, we say heat is a type of energy transfer in which there is no involvement of any mechanical work. It is a non-mechanical work involvement type of energy transfer. That is our heat. Yes. Now, it has been observed, other than this, somewhere else we do some mechanical work. We do mechanical work and get heat energy. At that time, what will say? How much mechanical work has been done how much mechanical work, how much mechanical work has been done to produce certain quantity of heat or heat energy. We say is the mechanical equivalent of heat. It is the mechanical equivalent of heat. The name we have given J, that is work done to produce same heat, or to produce certain amount of heat. If heat produced is if heat produced is Q calorie, then work done is W Wj. Heat is produced Q calorie. Then we say W is proportional to heat, or W is some constant J Q, or J is equal to W by Q. We say this is the J is now mechanical equivalent of heat. It is a proportional quantity and its value is 4.861. That means 4.861 joule has to be done to get 1 calorie of heat. If Q is equal to 1 calorie, then J becomes W joule. Then W means 4 point, J becomes 4 point, or W becomes, if Q is equal to 1, then W is equal to J joule. That is 4.861 joule. What it indicates? This indicates if 4.861 joule of work to be done to produce 1 calorie of heat. This term J is our mechanical equivalent of heat. In similar manner, we will discuss what is the water equivalent of heat. Now, let us study what is specific heat capacity. Heat capacity means how much heat one can absorb with reference to its mass. Suppose a quantity of mass, some quantity of material is given certain amount of heat. Naturally, we know once heat is given to certain material of m gram. Now heat is given, and definitely the temperature will increase. Suppose there is a delta T degree centigrade increase in its temperature. That means now new temperature T1, old temperature T, the difference is delta T. Then in that case, we say if the quantity of heat is equal to Q calorie, here Q is equal to, here the amount of heat given is proportional to mass and delta T, or Q is equal to m, some constant S delta T. or S became Q by N delta T. M in gram, delta T in degree Celsius, Q in calorie. Its unit is calorie per gram degree Celsius. This S is specific heat capacity of the material or substance. Specific heat capacity. Heat capacity. Specific heat capacity of the substance. That indicates if n is equal to 1, if n is equal to 1 gram and changing temperature is equal to 1 degree Celsius, then S is Q is equal to S, or S is equal to Q. S is equal to Q. That means it indicates specific heat capacity of any substance is the amount of heat is required for 1 gram of the substance to raise its temperature by 1 degree. To raise its temperature by 1 degree. This is specific heat capacity. And when the mass is specified, means 1 gram, for that we say it is specific. If whole mass is considered, what is the heat capacity for the whole mass? Now, suppose gas mass, when we say is M, the amount of heat required for m gram, for 1 gram, amount of heat is S, for 1 gram of substance, heat required to raise its temperature by 1 degree is equal to S. Then for n gram of substance, heat required will be S into M. This is the heat capacity. This is the heat capacity of the substance, or heat capacity is equal to specific heat capacity into mass in gram. This Q is Ms delta T. Ms delta T, or heat capacity now specific heat capacity into total mass of the substance. Another way to express this heat capacity is its molar heat capacity. That means how much heat required, the amount of heat required to raise temperature by 1 degree for, instead of 1 gram, we are taking 1 mole of the substance. 1 mole of the substance. 1 mole means Avogadro number of molecules. 1 mole is equal to Na molecules. That is 6.023 into 10 to the power 23 molecules. For this many molecules, कितने टेम्परेचर देंगे, so that their temperature will increase by 1 degree. This is called molar specific heat capacity. Molar specific heat capacity. capital C or capital C. If it is at constant pressure, we say Cp, means molar specific heat capacity at a constant pressure. If volume is kept constant Cp, then C at constant volume. In later stage, we will prove what is the relation. The relation between Cp and Cv. Cp is always found to be greater than, and Cp minus Cv will be some constant, that is universal gas constant R. This has been taken from universal gas equation. PV is equal to nRT. PV nRT. Here R is our universal gas constant, whose value is 8.31. This is energy, joule, work energy. Unit will be joule per. This is N is number of mole and degree centigrade. Okay. This is how we describe different types of heat capacities of any substance. What is water equivalent? What is water equivalent of heat? Water equivalent of heat. This is the mass of the water. This is the mass of water, that is in gram or in kg, kilogram, that required same amount of heat to raise its temperature by 1 degree. That requires same amount of heat to raise its temperature by 1 degree centigrade. Mass of water that required, the mass of water that require same amount of heat to raise its temperature by 1 degree for any substance that means mass of water that we require for the same amount of heat which will be supplied to the water to raise its temperature by 1 degree. For any substance which require same amount of heat to raise its temperature by 1 डिग्री सेंटीग्रेड। इसका मतलब ये हो गया कोई ऑब्जेक्ट दिया है जिसको हमने हीट दिया सपोज Q, और इसका टेम्परेचर इंक्रीज हो गया 1 डिग्री सेल्सियस, तो दिस इज सपोज Q कैलोरी। हमने कितना पानी लेंगे, हाउ मच वाटर विल टेक इन ग्राम, so that will provide same Q calorie of heat, और इसका टेम्परेचर विल इंक्रीज बाय 1 डिग्री सेल्सियस। दैट इज द वाटर इक्विवेलेंट ऑफ हीट। That means water equivalent of a body is defined as mass of water that require same amount of heat as is required by the given body for the same rising temperature। अभी हम लोग क्या कर रहे हैं कि 1 डिग्री टेम्परेचर ऑब्जेक्ट का बढ़ाने के लिए जितना अमाउंट ऑफ हीट चाहिए उतना अमाउंट ऑफ हीट कितने पानी को देंगे, सो दैट पानी का टेम्परेचर 1 डिग्री सेल्सियस बढ़ जाएगा, एंड दैट इज द मास ऑफ द वाटर इज इक्विवेलेंट टू, mass of water is equivalent to, we can say, water equivalent of this body। We can explain another way, water equivalent of body, water equivalent of the body is the mass of the water which is equivalent to this body which requires same heat, same amount of heat to raise its temperature by 1 degree। इसका मतलब heat capacity of water and heat capacity of body will be same। Heat capacity of water and heat capacity of body will be same। Suppose this is m1 kg of body and this is m kg of water, then heat capacity of body will be m1 h1 delta T। Here heat capacity of water will be m s delta T, it will be equal। In this way you can find out m is the water equivalent of the body, water equivalent of the body is m। Now m became m1 h1 delta T by s delta T cancel, then it became m1 h1 by s। Okay, in our next class we will continue with change of state and latent heat of the latent heat of the substance।